Welcome everybody. Please enjoy the big room you have here. Here's a Lessons for Life, a corrupted file system, no up on a USB stick. Shall we give him a hand to start him up? Yeah. You can do it.
Okay guys, so thank you my laptop for doing this, and well, I'm gonna do it live. Because after all, my talk was all about best practices in the use of C++11 when using asynchronous programming and not. Well, the idea of, I'm going to try recovering the file system. If anybody sees any activity, just wave a hand. The idea of the asynchronous realm, it was basically asynchronous and more, and I'm going to put a certain age on more because Thiago was supposed to be here introducing all the rest of C++11 and he won't be here. So maybe some of the information I'm going to say in the first 10 minutes are going to be redundant for you somehow. On the other hand, I really hope that this talk gives you a whole idea of how to use everything in which C++ and Qt5 offer to the developers. So, well, the intention was to start with a quick rundown of the slides that I had, which had very interesting pieces of code, which I hope I can remember by heart, I think. So let's start by seeing what C++11 brings to the table. So C++11 and Qt5 are a match made in heaven when it comes to productivity. Several new features that have been introduced really make the developer's life way, way easier than it used to be. And of course, some of these features bring new advantages and new caveats with them. So we're going to also explore how we can do things completely wrong in some regards, and how we also in Qt are trying to improve your experience by introducing new features, such as the one we introduced in Qt5.2 and 5.3 to make your life even easier and more safe when dealing with those things. So for those of you who are completely new to C++11, I've been asked many times if, for example, will my C++ code compile if I use C++11? Well, the answer is yes, because C++11 is nothing but an extension to the language. So we are still dealing with C++ as it is, and we are just introducing new features and keywords which are the extension by itself. So let's start by having a look at some of them. Wow. This is going to be hard. So let's start from one. Given that the order somehow got crapped, I'm going to start with one of my favorite one. Like you probably all know, stuff like this, I guess. Oh wow, this is not even an Italian keyboard. This is going to be so hard then. Whoa, is there a dragon I should slay or some kind of things? No, I can handle this. Yeah, no, I can handle this, I think.
Well, people can't see you.
Oh, great. So there's a dragon up there I should slay it, maybe. You won't be alive anymore, right?
There we are.
Oh, great. So, well, I guess you're all familiar with enums. I don't know, 1, 2, and 3 maybe. So, I don't know if you ever tried having in the same namespace stuff like this. Oops, sorry. This is gonna be hard. Stuff 2, I don't know, I can do maybe 4, 5, and 1. So I guess you all know this gives a big fat compile error, because of course 1 as a name is already defined. Now C++11 does this neat thing called enum class, aka strongly typed enums. So if you ever happen to want to use an enum in a namespace, for example, or have the same name, the same enum defined in two different enums in the same context, now you can do that. Because of course this means strong typization, which also means that you can do neat things like for declaring things. If I do something like enum class stuff as a for declaration and I define a method, I don't know, void whatever, in which I take a stuff parameter, this is actually valid code, because now I can forward declare enums. And most of all, I can also give it a strong typization. So if I want this to be an integer, I can do that. If I want this to be an integer of 32 bits, I can do that. So this is a really neat feature and one of the, I think, most underrated things that you see in C++11 these days. And not even many people talk about it as much as they should. But of course, enums are a fundamental part of your code workflow whenever you deal with flags, for example. And this really helps in making your code safer and have more type consistency among your code. So, but whoa, okay. Luckily, I am a Qt developer, so I can handle this. If this was macOS, I would be in big trouble. Anyway, well, not really. Unexpected inconsistency. Have you ever seen this error, by the way? That's my first time ever. You always learn something new. So, moving forward, constant expressions. Now, this is a lovely feature. Const extra is usually, whenever you start talking about it, a drop-in replacement for stuff like this. Whoa, got it at the first time. Well, asterisk, why? So, of course, this thing, as you all know, replaces inline what you meant with multiply with x asterisk y. Constant expressions are a bit different. So, for example, I can define an integer multiply here, in integer x, integer y, and define this as, well, exactly the same. Whoops. Come on. Okay. Return x asterisk somewhere here. Great. Special effects for you. And so, what is the meaning of these constant expression? Well, first of all, there is a very high constraint on how you can use constant expression. In particular, the usual rule of thumb is that you can use constant expressions only on functions which have a single return statement, and use constant variables, in this case, the arguments that you gave to the function. So this thing is actually interpreted by the compiler at compile time, which means that the compiler knows that these variables are into a context. It is capable of computing the value at compile time. And so this is basically putting your code on steroids, because of course it runs really fast at the expense of a slightly higher compilation time. The neat thing about const extra is that it applies to classes as well. Now this is going to be a bit longer, but we're going to try it anyway. And this. And this. Now this. Great. So supposing that we want, for example, to create a const extra constructor, we usually can't do that. So if we were to do stuff like this, in which I initialize a member, which is, I don't know, underscore x, and underscore y, I can do that. And this is actually a valid code. And it's going to be interpreted at compile time as well. Of course, I can define any other number of methods in this class declared as constant expressions, which will be computed at compile time in the same way that the function multiply did, as long as we are using initialized members like x and y, which is the only constraint in this regard. So this is really a powerful feature which helps a lot in your code. Now, moving forward, I will just skip to the meat because, of course, I guess my time will be slightly cut by the fact that I don't have the slides with me. So, coming to the asynchronous realm, one of the most easy ways we have in Qt for doing asynchronous things is one of the most common functions, which is connect. Of course, as you all know, connect can take a last argument, which is Qt connection type, which can be auto connection, direct connection, Qt connection, unique connection. What does this mean? If I do a direct connection, I'm usually invoking the method straight away. So whenever I fire the signal, if I am in the same thread of the sender, I will be receiving the signal as if it was a method call. If I'm using a Qt connection, I am getting the signal through an event loop, which means the signal will be delayed some way in the next run of the event loop and will be actually an asynchronous call. Now, let's define two realms of how we deal with asynchronous programming here. I'm going to be talking mostly about real asynchronous programming, which does not include threads. So returning to the event loop as soon as possible, trying to make my program go forward and forward and forward without blocking the execution at any time, and trying to return. So as Qt features a very powerful event loop, we always should try and strive to get the most out of it. So posting events is cheap, getting events is cheap as well, and it really allows us to do a clean path towards our goals, especially when we are dealing with several objects which need to be initialized in a sequential or a parallel way. Of course, we will see how to use threads, but Ivan will be holding a very nice talk this afternoon, and I suggest you to follow it, which will be talking about QFuture and the asynchronous programming in a more multi-threaded realm. So What's new in Qt5? Well, you all know about this very neat syntax, which is the new connect. Wow, got it as the first one. Signal 1, no, signal 1, object 2, and object slot 1. So this is the new feature in Qt5 which allows us to connect to function pointers and function pointer members, thanks to Oliver, who's sitting here. But of course, with the new C++11 things that we have, we could make so much better out of it. For example, using lambdas, which are one of my favorite features of C++11 at all, and one of the main arguments of this talk as well. So lambdas have pretty much this shape. QDebug. Hello, lambdas. So how it is declared? We have a bracket here in this, which is the capture real. So whatever we put into that belongs to the context we are considering, including this, of course. And it's what is going to be taken as a context in the lambda execution. So whenever we declare lambda, the very bare form, which is this one, we're creating a complete new context which doesn't inherit the context or the stack of the execution we are considering. So we are always forced, and this is a good thing, we will see why, to capture things whenever we want to use them. Then we have a way for passing arguments to the lambda. So I can pull in, I don't know, an int x, for example. And this is pretty much, as you expect in C++, standard method definition, and of course we also have a way for defining return types. And this is the complete syntax of lambda as we know it. Now the need of returning a specific type is not actually needed when we are in the lambda realm, because of course we can use the new keyword, which is auto. Auto is basically trying to weakly typize C++ in some ways. The point is that whenever I use auto, the compiler tries to interpret the return type or the type of the variable I'm declaring and make it basically a low-level typization of the whole thing, which is somehow safe whenever you have to deal with lambdas, because otherwise you will have to write something like this. Because lambda is nothing but a standard function which usually has a huge fat template argument defining the arguments, the return type, and more of these things. So it is usually safe to do stuff like auto my lambda and declaring whatever you want. But of course, the real power of lambdas lies in the inline declaration, just like I did in QObjectConnect. So this was the 5.1 word where we actually could just do this. So the first implementation of the Lambda Connect was tied to the concept of having a direct connect and nothing else. Now this is pretty obvious. As you see, we have no receiver object, which is correct because of course lambdas are declared in their own context, as we have seen. But of course, if we wanted to do something more complicated or prevent some typical caveats that you have when connecting to lambdas, we will need a context. So I will show you a very brief example of why things could go very bad whenever you connect to a lambda. So suppose we have, I don't know, a job, our object is a job manager, and it has a signal JM job removed. And I want to connect this to a lambda, which is taking this as an argument. And this is a transient object in which if the removed job is my job, so suppose I just passed an ID, of course it is pseudocode, but this is going to be enough, I guess, for you to get everything. So if ID is equals to my member ID, delete the object. Now, this is a typical situation in which I lost several moments of my life in understanding why my program was crashing. So if you can get it at the first look, I gave you a hint, but, well, good job. But I will try to explain what happens. So whenever we instantiate a connect, we are allocating a meet object connection object, which is a new concept in Qt5, which encapsulates all the logic which is needed for calling the function either in a direct or a queued way. Now, we are connecting a job manager, which is in this case a persistent object, so this object will be staying alive probably for the whole execution of the application, to a lambda function, which is deleting this. Now, whenever this object is deleted, of course, the meet object connection is not deleted at all. which means this connect will persist. The next time somebody removes a job, my application will crash. Bummer. Because of course, whenever you grab the context, which is this, you're not telling anything to QObjectConnect, because QObjectConnect doesn't know anything about the Lambda itself. The context we are passing is merely for the context of the Lambda. So it's pretty obvious that the connection persists. There's many ways to get around this. For example, we can have the connect return QMeet object connection and manually disconnect it into the Lambda, which can be done this way by importing by reference the connect, and of course trying to disconnect it into the function. But of course this is kind of very easy to forget and very easy not to spot whenever the time comes, because of course this kind of error comes at the most random moments whenever you delete a job or whatever else, and it's really hard to spot. So what we did in Qt5.2, and this is a patch I made with my company and with the support of Oliver, which was invaluable in this regard, was this. The capability of adding an argument context to the connect to Lambda function. So this brings up several results. So the first obvious one is that this thing doesn't crash anymore, because whenever this is destroyed, the connection is cut, which is exactly what you expect with a standard connect when you connect an object to another object. Whenever one of the two falls, the connect falls as well. So this makes this code pretty much safe. But this also allows us to do very neat things, which are really helpful in the way we program. For example, to specify Qt connection. So in this way, we are no longer calling lambdas directly, but we are posting an event to the event loop and returning to the Lambda whenever this is done. And this is a really neat way of doing your things, especially if you consider classes like kjob. Maybe you're not familiar with kjob at all. I will try to stub it for you. I don't remember the real API at all, but I will try to just give you the principle, which is usually void start and virtual void start imp. So I'm pretty sure that at some point of your programmer life, if you ever programmed at all, you kind of run into this kind of things. So you have an object which you have to re-implement, which takes an asynchronous way of initializing or exploiting an operation at all. For example, we also have a similar concept in other Qt libraries, and in fact kjob maybe should be pushed in Qt at some point, in which we can create real asynchronous operations, not necessarily running in a different thread, or for example objects which are not initializing themselves in the constructor but in a separate routine, which is usually triggered by start. Now start usually resolves to QTimer single shot 0 invoke the method. So just invoke this at the next run of the event loop, and we're going to talk about QTimer in a while as well. So whenever we deal with these things, we might have, and this is something that I've seen many times, both in my projects and in other projects, we might have a situation where we have several of those kjobs, which we need to initialize sequentially, and maybe we want to wait a little before, after one is initialized before doing the other. So with all of these new things, we can basically chain up initializations in nested lambdas. So suppose I am importing in the context of this very first thing, job 1 and job 2. I could be saying, okay, initialize job 1. Now, this is really ugly code, but still. Job 1, start. And I could say connect to job 1, and whenever the job is finished, well, just throw me into another lambda, this time capturing job 2, inception. What happens here? Well, first of all, I might decide, well, I'm not really doing very cool things inside this kjob. I really want to be safe, and I don't want this procedure to be called before I'm certain that everything which this thing is doing into the event loop is expired. So I'm just posting the event. In this regard, I do need to provide the context to all of this. There we go. Now this chain of initialization, which might seem ugly written this way, and in fact it is, properly indented is not so bad. And well, this comes up to one of the main features of the lambdas. Whenever you're programming libraries, one of the things you should have noticed by now is that we have not defined any symbols at all. Now this is invaluable whenever you're dealing with binary compatibility or source compatibility at all, because you can change pretty much any of your internal logic by the minute, and you're not binding anything to a specific API. In a previous word, you will have to declare several Q-private slots, for example, or several private members. This thing is basically no more whenever you use lambdas. And this is by itself a very big advantage in doing these things. And of course, the fact that you can somehow encapsulate in the very same logical portion of code the processing of what you're doing. So in this regard, there is a very, very neat use case I really wanted to show you, and I will try to reproduce here somehow. Maybe with the help of do I have the internet? I think I can probably do some special effects with an internet. Maybe. So, Unix signal handling. Now, if you ever program for Unix, you at some point had to deal with sigterm, sighop, sigkill. For those of you who are not familiar with the Unix word, how it works is basically every process in Unix can be sent a signal. This signal can have a value, which is usually term, hop, or kill, for example, and the process can react in a non-standard way if it's able to capture this signal and somehow and do specific processing. Of course, you should somehow try to adhere with the Unix standards, but you can basically implement everything. Now, there is a very standard way in Qt in which we usually deal with those things, and I will show you as soon as the internet works. Basically, the old way of doing this kind of things was taking a QSocket notifier and using a socket trick to trigger the signal in a C function and sending a socket signal back to the C++ code, which then was capable of connecting the socket signal handler to an object in Qt. Now, this was kind of tricky, but of course it worked very well. But with these new things I've just shown you, of course we can do better. So one of the things I didn't like about the approach is that you usually had to define something in your object which was taking care of handling the signal. This is kind of a broken concept, because usually you really want to control the execution in your main function, unless you're using some specific application classes. But in this regard, the problem was that we could not connect anything to what was not a Q object, but now we can. So I had a very nice routine I will probably share with all of you guys after the talk, which was showing how I could rewrite a main function by using lambdas only. And well, if it doesn't work, I will try to reproduce it here. So as soon as you trust me that the socket magic works, because it's like 100 lines of code, so I guess you will trust me on this, I will show you a very interesting way of dealing with these things in a main function. So I have my int main. Pseudocode, because it will be definitely too long otherwise. For example, suppose that my application consists of several objects in the pretty much same fashion of K-jobs, which are initializing themselves after a while, and I need to instantiate, I don't know, a core, a plugin loader, and whatever's in my main function. What I did was this. I define a lambda called startitUp. Now, in this regard, I usually like to do this. This is a really unsafe thing, and I do not advise you to do that. Ampersand inside those brackets means I'm capturing the whole context by reference. Now, the only reason why this is safe is that I know that this context will persist throughout the whole execution of the program. But of course, doing this is really dangerous, because if something allocated on the stack is referenced after the function goes out of context, boom. So be careful, but in the same regard, don't get tricked and use the easy way, which is this. Because this means hard copy the context, and maybe you do not want to do that. So when I started using lambdas, I was just getting the drag and equals. At some point, I realized it's not exactly so cool to do in all the cases, because it of course works with pointers, but if you allocated stuff on the stack, like integers, strings, or whatever, this does a hard copy. So be careful with that. Usually, the best idea is always capturing what you need, also because it gives you a better control over what you're doing. But in this case, we'll be safe with this. And in my startitUp, I define blah, 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 and all of my code for the initialization. Then I have a shut it down, in which I do the very same thing, and I do my blah, 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 of course, in the very same regard. So good at doing this. Of course, with this at the end. And so, where's the magic? When I usually have to handle this, we suppose that in this area we instantiated all of the socket magic that we needed for handling the Unix signal, which is something you can find easily on the internet, by the way. The trick happens here, because of course now I'm capable of using QObjectConnect in my main function. I used to be able to do that before, but I didn't instantiate any QObject before that. So what can I do? I have my, for example, socket notifier for the hop signal. I connect it to the signal, which I don't remember the name of, but I think it's somehow socket something. So I will call it socket something. And of course, in this case, I can connect it to a Lambda. So what can I do here? I can simply take it into my startItup function and be happy. And of course, my shut it down. What can I do here? Well, of course, hop means I have to reload my application. So in this case, what I'm going to do is simply shut it down first. And we suppose that shut it down, which I can invoke as if it was a standard function, of course, is deleting an object we have in our stack, which is called core. What can I do then? I can do this. I can connect core, QObject destroyed, to, guess what? startItup. Of course, you should invert these two instructions, but you get the drill. So you're basically declaring inline functions, and you can connect to them and use them for driving your application logic. And if you were wondering how do I start my application, of course, it's quite easy. That's pretty much how the whole drill works. So you see, it's a very interesting way of dealing with these kind of things, and a really neat method of like overcoming some limitations that you usually have when you deal with Unix signals. And this can really be applied to many other cases in which you do not want to have a Q object, which is usually heavy to construct and delete, of course, but you still want to use the features of connect. So this is a pretty amazing thing, and I will be sure to publish my slides after my hard drive hopefully gets back to life. But talking about something different, QTimer single shot. So the bad news before I even begin is that this that you're going to see is going to be in Qt5.3 and not 5.2. So sorry about that, we didn't make it in time. You maybe know about the syntax. Which of course lets you call myslot in an asynchronous way. This means literally wait until the event loop returns before calling myslot, then call it. That's the exact meaning of this function. Of course, nothing prevents me to do that and tell him, well, call this after 1,000 milliseconds, sorry. But I wish all of you wanted to do something like this after seeing this talk. Well, the good news is that in 5.3 you can. And you can connect lambdas straight onto QTimer single shot, which is great because this means real inline asynchronous code. So I'm just going to say, okay, I'm going to do this procedure, then please do this later. I can continue with my synchronous procedures and please do this later. So I can stack operations without the need of instantiating a new object or doing complex logics straight in line into my code. Again, this is great in the context where I do want to have everything in a single logical block. Quite neat. And of course, I can do a context-based single shot, which means that if object gets deleted, my single shot won't be called. So we tie the lambda to the context. Now, talking about caveats, maybe some of you might be tricked by thinking that if I do this, and then I do this, well, suppose that I declare t before the other one, and t, of course, this lambda will be called in a separate thread. Well, the answer is no. Why? Because of QObject affinity. So we also have to remember that when we talk about context, there's a reason for that. We are not talking about threads, but this still means that if you are given a context which belongs to a different thread than the one we are executing it into, this thing will be executed in the context thread. I'm stressing the word context because whenever you instantiate a Qt thread, it does not belong to the thread it will spawn because of QObject affinity. So you all know that a QObject usually lives in an event loop, and every thread spawns its own event loop most of the times. Now, whenever we tie an object to a thread by using move to thread, for example, or by creating an object in that very thread, that object carries with him the event loop of the thread we're considering. So we always have to do stuff like this. Now, if I do this and I call single shot on O, in this case, this will be called in the thread spawned by QtDD13. This works. The other one is not guaranteed to put your object in the same thread. We didn't do an overload, which was carrying a Qt thread instead of a Q object, because it would have been very confusing, of course. But this also allows you to see one thing, that we basically kind of replaced what was Qt concurrent run, which still accepts lambdas. But in this regard, that precise syntax of QTimer single shot allows you to specify consistently the thread that your function will run on. Whenever you use Qt concurrent, you have no guarantees on which thread exactly you're going to be running the function. So Qt concurrent is great for something asynchronous in a multi-threaded way, of course, whenever you don't care about where your code will be executed. On the other hand, if you really care about your code being executed in that specific thread, or you do not want to have a Qt thread pool for any reason, because maybe your device is limited and you do not want to have more than 2 threads, for example, you can always use the new single shot syntax, which ties to a specific thread your context. Now, I basically showcased pretty much 50% of what I wanted to do, but still, I pretty much remembered what I had to do, which is great. I will briefly run through verbally the other things I didn't mention, and you will find in my slides after the conference is over. Great things I didn't talk about, the use of stateful objects. For example, QtBus pending call watcher. So if you ever use QtBus or, I don't know, QNetwork reply, for example, those are 2 very good examples of an object which is usually in a stateful state. Sorry about that. But it's not guaranteed to be running whenever it's created. So how does it work? I usually create a QtBus pending reply from a dbus call, which is exactly like a get on an HTTP network, pretty much. Consider it like that. This object carries the state of the reply in an asynchronous way. So under the hood, the Qt event loop is sending calls to dbus and getting the result back. Whenever I want, I can create a QtBus pending call watcher out of this dbus pending reply, which of course manages the state and emits signals whenever the call is over. But there is a chance that I create a QtBus pending call watcher whenever the call is over. So this thing doesn't guarantee me that I will be actually creating an object which will emit a signal. It's likely that this object might have emitted this signal already when it's created. So if I connect to the finished signal, there is a small chance, or a high chance, depending on how you structure your code, that the signal finished will never be emitted. Now again, this is a very neat use case for lambdas, because if I do not want to define another slot or another symbol in my code, I can simply do an auto on finished, define my lambda, and do if, w is finished. Oh, that was harsh. No. How does this thing work? I pressed something, I don't know. Well,
that's going to be easy to help you with.
Yep. There you go. So if W is finished, I can call straight unfinished. Oh, that's ugly code, but it works. Else, I can connect my finished signal to my lambda. So in this regard, lambdas are really useful whenever you deal with stateful objects as well. And this is a situation in which you find yourself quite often if you're doing lots of asynchronous networking or asynchronous dbus calls, which is usually what you have to do whenever you deal with these kind of things. And I guess this is pretty much it, because my time is running short, and I really hope you enjoyed this live presentation. And again, sorry about my hard drive. I will have a talk with my PC later. And if you have questions, well, my name is Dario Freddi, and you can find me at dario@ispirata.com. Ispirata is the name of my company and the company behind many of these patches, and all of my time have been sponsored by Ispirata itself. So you can reach me out to that, or LinkedIn, Facebook, Twitter. If you have any other questions, or I will be around until the end of the day. And if you have questions now, of course.
Yeah. We have still 5 minutes, so if you have a question, just... Anyone? No question?
I've been too good.
Okay. Yes, then thank you. Now it's lunchtime, and we have 1 hour for that. Oh, sorry.
I think there was a question there.
Okay.
Oh, okay.
Hi.
Hi.
There was a lot of talks about whether the C++11 features could be used in Qt programs, because some of the Qt programs have to be compiled with old compilers which doesn't support them. And how do you, if you deal with such situations?
Well, so for features like lambdas, first of all, if you're using GCC, which is likely if you're developing on Linux, C++ features have been introduced sequentially from 4.4 on. So 4.6, 4.7, 4.8.1 is actually the first version of GCC fully compliant with C++11. Qt offers you neat things like, for example, QtDD13 const expr. So as we've seen the constant expression thing before, this macro expands to const expr in case your compiler supports that, or expands to nothing if your compiler doesn't. This is true for other keywords, for example, QtDD final or QtDD override, which are other two keywords I didn't talk about, but are quite common and basically can be appended to functions. If you want to specify one has to be an override and one cannot be overridden. And so you have a set of keywords defined by Qt. For example, QNullPointer. NullPointer is not even worth to talk about because everybody knows about it. But it's basically a replacement for 0 or null. QNullPointer expands to 0 in case your compiler does not support nullPointer, or expands to nullPointer in case your compiler does. So whenever you're programming multi-platform, you want to use these keywords to take advantage of those features. If you have a concern about your compiler, for example, LMSVC, not supporting the features, I suggest you not to use lambdas, for example, because this really cannot be wrapped in any ways. I do understand it's a pain because people who start programming with these new paradigms are like, I cannot really do anything on Qt4 anymore after I got used to this, so it's like I'm addicted. And it's hard, but for the sake of consistency and for the sake of being compliant with compilers who are not really caught up with this C++11 thing, of course, you really have a very small subset of feature you can use, and Qt tries to help you with those you can. Of course, remember that const expr gives you a very high performance gain and somehow should be used with a grain of salt, because if you're doing lots of stuff on const expr and you compile on a platform which doesn't have const expr, it's going to get quite nasty. I wanted to talk a bit about variadic templates as well, but I think Oliver is going to cover this in You're Not. Okay, great. So, if anybody of you is going to be in San Francisco, I'm going to do this talk again, hopefully with a sane hard drive. I'm going to talk about that as well, but variadic templates are another very neat feature in C++11, which cannot be used throughout, of course, Qt expressions, which allows you to define a non-numbered number of arguments to a template. And this is very widely used, for example, in QObject Connect. So whenever we are dealing with the new connect syntax, we are usually allocating a structure, which is a function pointer called Q function pointer, which is usually a set of template functions. But if you enable C++11 on compilation, and note that this is all in line, so this does not depend on how Qt was compiled, but depends on how your application was compiled, those 6 overloads translate to one single overload, which carries a variadic template with it. So in this regard, for example, one of the most obvious thing you can do with this, if you have a signal with 8 arguments, you cannot use the new syntax unless you're using C++11, because in this case, the variadic template can accept any number of arguments. Whereas for the sake of being not so verbose, we just support 6 parameters to the signals and slots in the non-C++11 syntax, because of course we cannot use variadic templates. This is a very advanced feature anyway, and it deserves, I was just supposing on running through it exactly in this way with some sample code, but it's really an advanced feature which needs to be explored in depth, and maybe this could be something for next year, once also the compilers will hopefully have code up. But, well, rule of thumb, if you're on Linux, you're safe. If you're on Windows, think twice about it.
Did you learn a lesson of life today?
Yes, back up everything before the presentation, like 10 minutes before.
That was a great presentation, nevertheless, wasn't it?
Thank you very much.